Today's video is about structure of an atom. If you find the video informative and useful, kindly like and subscribe my channel. Atom, it's a fundamental unit of a matter. So this is a structure of an atom. So there are different parts of an atom that you call as subatomic particles. The first one is a proton, neutron and electron. So protons are positively charged present in the nucleus. So they are inside this is a nucleus. So you find the proton here and the neutron here. This blue and red color has been differentiated. This is the proton and the neutron here. So neutrons, they are neutrally charged. They don't have any charge. And electrons are negatively charged and these orbit the nucleus. So they are in particular orbit or in shells and they'll be rotating around the nucleus. So these are electrons. So protons and neutrons are found inside. So protons carry a positive charge, neutrons no charge, and electrons carry a negative charge. Electron shell. So what are these orbits? So electrons revolve around the nucleus in a different orbits. These you call them as shells, or they are also known as energy level. The shell close to the nucleus is called as the first one is called as a K shell, and next comes as a L shell, that is the second shell, and K, L, M, N, it goes on. So the number goes on depending upon the size of the atom. So what is electronic configuration? So electronic configuration is nothing but the distribution of electrons in different shells. You call them as electronic configuration. So what are they? Each shell has a limited capacity to hold electrons. So there are two rules in that. The first rule, so the maximum number of electrons which can be present in any shell of a given atom is given by the formula 2n square, where n is equal to the number of shells as counted from the nucleus. For example, this is a K shell. So K shell is the first shell. It can be counted as 1. The next shell is L shell. This will be counted as 2. L. So 1, 2, 3 and it goes on. For example, K shell, the shell number is 1, the first shell. So the formula you have to apply 2n square. So n, if you put the value as 1, it is 2 into 1 square is 1. So 2 into 1 is 2. So the maximum number of electrons in the first shell, K shell, can accommodate only 2. Then the second shell, so it is 2 into 2 square. So it is 2 into 2 is 4, 4 2s are 8. So it maximum it can accommodate 8 electrons. And M shell, it has 3. So 2 into 3 square is 9. So 9 into 2 is 18. So maximum it can accommodate 18. And the N shell is 4. So 2 into 4 2s are, it is 4 square is 16. 32 totally. So it can accommodate 32 electrons. This rule 2, it's an important rule. So electrons in an outermost shell cannot have more than 8 electrons. So this is an important one. So we got as, for example, in the fourth shell, we got it as 4 into, that is 2 into 2, 4 square, that is equal to 32. So they can't accommodate 32. So the outer shell can have only 8 electrons. That is a rule. So we'll go for some example. For example, calcium it has atomic number is 20. So it has, what is the electronic configuration? How we'll write? The first K shell will have 2 electrons. Then the next has to accommodate 8 electrons. And next one is 8 electrons. And then finally it is 2. So this distribution of electrons is called as electronic configuration 2, 8, 8, 2. So calcium, the first shell is 2 is here. The next shell is 8 electrons here. And the next third shell is 8 electrons and the last is 2 electrons are here. So electronic configuration is 2, 8, 8, 2. Now in the case of oxygen, the electronic configuration is 2, that is totally atomic number is 8. So 2, 6. So M and L shells are not there. So first shell is 2 and the next one is 6 here. So when is an atom stable? For an atom to achieve stable electronic configuration, it must have 2 electrons in its first shell, that is the outermost shell. First shell means if it is the outermost shell, it should have 2 electrons. That is only one shell is there. Then it is outermost shell should have 2 electrons. Like in the case of noble gases of helium. Now, or the next condition is 8 electron in its outermost shell, like that of noble gas of other than helium, neon, argon, krypton, like that. So because of the instability electronic configuration, most of the atoms are very active. Whereas these noble gas elements, helium, neon, argon, krypton, they are inactive. They are stable. Because of the stable configuration, they are inactive. So most of the atoms are active because of their unstable electronic configuration. For example, sodium I have given here. Sodium electronic configuration is 2, 8, 1. So it is 2 here and 8 here and 1 electron. So molecule. So atoms of the same or different elements combine to form a molecule. So the second point about molecule is molecules are they exist independently, whereas an atom may exist or may not exist independently, whereas molecules, they exist independently. For example, hydrogen atom. So it has one electron here. This is another hydrogen atom. They both combine to form a molecule. So what happens? They have a single, when they combine in its outermost shell, they have two electrons. So molecule of hydrogen is stable. This is stable and they exist. Whereas hydrogen atom, they cannot exist. They'll be reactive and they'll be very active and they want to combine and form a molecule. The next one is atom, oxygen atom. So oxygen electronic configuration is 2, 6. So still they need 2 more electrons for this atom also and this. So what happened? They combine to form this 2 electrons. So finally this is shown in the outer shell alone. It is shown here. So 6 here. So here 6. So 1, 2, 3, 4, 5, 6, 7, 8. So mutually it has been sharing the electrons to form. Mutually, when you take this atom, they are getting 8 electrons. When you take this atom, it is getting 8 electrons. They are sharing. So this is a covalent bond. Here also it is a covalent bond. So this sharing of electron is formed, and this O2 exists. Oxygen atom molecule exists, whereas oxygen atom is unstable. Next, water ions. An ion is an atom carrying a positive or a negative charge due to the loss or gain of electron. For example, sodium. This is an atom 2, 8, 1. So it has 1 electron in its outer shell. So during chemical reaction, so what happened? It may lose 1 electron from outer side and it forms. So it may get this will become the outer shell now. So this may have 2, 8 now. This is now on losing an electron, it becomes a positively charged ion. This is sodium plus Na plus ion. This is sodium ion. So an atom on losing an electron, it becomes electrically charged particles known as ions. So ions may be positively charged or negatively charged. Generally, we can say that all metals, they carry positive charge and non-metals carry negative charge.